Now it's time to install the load balancer controller. And for that case, we need to test whether the kubectl local exec command worked and whether our kubeconfig was correctly updated to allow us to connect to our cluster. To do that, we can run a simple kubectl command like this one to get all from all namespaces. And as you can see, we can comfortably connect to our cluster from our local machine. The next step will be to run the Helm command that will be installing our load balancer controller. For that, we'll be running the Helm command using this values.yaml file that is found within the load balancer subfolder. Before we do the installation first, we need to add the load balancer controller chart. To do that, we can just run Helm repo add EKS. So we'll name our repository as EKS and it will be coming from the EKS charts repository right here. Once you've added the repository, you can list it using this command, helm repo ls. And you can see we have our repository among the local chart repositories that we have. Once you have the repository, it's time to run the helm installation command. I like using upgrade with the install option because it usually keeps your CI pipeline intact. If the release you are installing does not exist, it will be installed. And if it does exist, it will be upgraded. The namespace will be kubesystem and the release name will be AWS LoadBalancer Controller, and then it will be installed from the repository that we just added named EKS. The chart will be fetching from that repository will be named AWS LoadBalancer Controller, and I will be using a values file that will be coming from the current repository. Then LB will be controller subfolder, and then we'll be using the values.yaml file. And with this, we can just press enter. So Helm will use the Kubernetes config that our kubectl uses. And remember, we just configured our kubectl to use our cluster's kubeconfig using this command on our localhost. Once installed, it will show you the revision 1 status deployed. If you get any errors, you'll need to debug those. You can also share them on the chat. So with this, you need to give it a few minutes depending on how fast Fargate compute will be provisioned. And then you can just check kubectl get pods namespace kubesystem. You can see our controller is running, so give it a few moments. You can also check the logs by running a similar command like this, kubectl logs namespace kubesystem, and then we enter the command follow and the pod will be this one. So you can choose any of these pods. When you check the logs, they'll show you what is happening, so we wait until the pod is ready. So you'll see some timeouts while it's still being set up. When you go to the console, you can also see whether the Fargate profiles are ready or not. We can check it again, see if it's ready. Yes, and you should be able to see logs like this, just showing you what is happening. So this might happen after the pod has restarted once or twice. If it takes more restarts than those, there might be an error, so make sure you use the kubectl logs with an option to follow the logs and then choose one of the pods so that you can see the issues. If you cannot be able to see the logs, you can describe the pods. When you describe the pod, it will show you whether it can find the matching profile, and for the profile not being found, you'll see an error like 0 out of 2 matching nodes found or 0 out of 1 matching nodes found, depending on how many pods the load balancer controller is trying to provision. If you can't find errors from the pods, you can describe the deployment. So we've confirmed our load balancer controller is running successfully. You can just get the pods. And as I was explaining, you can see we had 2 restarts before our pod was ready. So sometimes you might find one of these pods had 1 restart, the other one had 2 restarts, or both of them had 2 restarts. With the controller ready, it's time to create our SCM certificate that will be used within our example resources right here. Before we do that, let's open the values.yaml, and in the values.yaml you can see we are creating a service account. In the AWS documentation example, the service account is created manually by you, whereby you specify the role ARN, but in this case, we are creating the service account using the Helm chart itself, and then we have to specify create true, and also we have to make sure we pass in the correct role ARN from our infrastructure setup output. If you do not pass in the correct role ARN, then you'll get errors.